our ASME staff, the DC office, work on this. We also had our NIST staff at the Advanced Manufacturing National Program Office. And they both work together very, very closely to arrange today's program. So please join me in thanking them for all their work. So now we are privileged to be joined by Congressman Bill Foster, and co-chair of the House Congressional Research and Development Caucus. Congressman Foster represents the 11th Congressional District of Illinois. He is the only PhD physicist, so he's someone who really understands what we do. And he serves on the Science, Space, and Technology Committee, where he has fought for evidence-based policies and forward-thinking approaches to some of our country's most pressing issues, including climate change, energy innovation. He has been an advocate for sustained federal funding for scientific and engineering research. And I must tell you that on the train over here, I checked his website, and I think he's the only representative in Congress that the first paragraph on his website has to do with science. And even I could not understand what he says. He was doing research. But I did catch one thing that's very important for me to mention. He started a technical company when he was 19. And that company is still thriving today with 650 employees, and they manufacture theater lighting equipment, which is marketed around the world and manufactured in the United States.
Thank you all. That was a wonderful introduction, so thank you. I sometimes introduce myself as saying that I represent 100% of the strategic reserve of physicists. But I am also, and I'm here actually with my hat on as the co-chair of the R&D caucus. I am the only PhD physicist, but there is also one other PhD scientist, a newly elected Republican, Jim Baird, who is the co-chair of the R&D caucus with me. And it's just wonderful. For a long time, I was the only PhD scientist of any kind, so I was getting old. But I'm also, probably the only, to my knowledge, the only machine tool programmer, or the only integrated circuit designer. I'm almost certainly the only superconducting, 100,000 ampere superconducting power transmission line designer in the U.S. Congress. I don't want to overclaim. But, inside of me is a little tiny small businessman. We started our company, my younger brother and I started it when he was 17, I was 19. And we had this idea of taking the newly invented microprocessor and using it to control theater lights, which had never been done before. And so we started the company in my basement, and then after a while, Dad kicked us out of the basement, so we moved into my bedroom. And then when we got our first order, we moved into a tiny little shed in a cornfield. Great big building in a cornfield, which actually now we have to update our website because it's over 1,200 employees. Wow. And we've kept all of those jobs in the Midwest, which is something I'm really proud of. That is not easy. If you're a manufacturing business, there are these consultants that will come to you and say, okay, we will come and offshore your entire manufacturing process. They'll come in and offer to photograph your assembly line and come in and have workers, have your workers train people from other countries and set up an assembly line on a turnkey basis in some Chinese city you never heard of. And then they will work you through the numbers to show how you will be personally more wealthy if you do that. And for 40 years, my brother and I have been saying no to that, and I'm very proud of it, keeping those jobs in the Midwest. But it is not easy. And this recurrent thing of currency manipulation has just killed U.S. manufacturing. A lot of the manufacturers I know that threw in the towel, threw in the towel in the early 2000s when there was an artificial 40% manufacturing advantage in China and some of the other countries of East Asia. And so that is something that should never be allowed to happen again. One of the few areas where I actually agree with the current administration on is to keep our eye on that. But also, you know, it's important what you're doing here to highlight to Congress, you know, the importance of manufacturing. You know, it is very much part of our DNA, and I think we're losing. And I worry a lot of the next generation of young kids who are all about like writing apps and stuff. They're heroes, and I'm going to start a business to write an app. You know, and that's not, maybe some of them should do it, but that's a business that's too much like being a movie star to me. You know, a tiny, for one thing, hardly anyone who writes apps makes a fortune. You know, a tiny number of them become billionaires like movie stars. The rest of them don't make much money. And there's something not quite right with our economy when those become the economic heroes for young kids coming in. You know, the real muscle of this country comes from manufacturing and for actually building stuff and adding value, taking raw materials and turning them into higher value products. And a lot of that, more and more of that has to become robotic. You know, we had a hearing yesterday on the Science Committee about the crossover as batteries become cheap enough to reach a point where electric cars are just cheaper than gas cars. Okay, and we're having probably a year or two of having that as more cheaper batteries come online. But that doesn't mean there's going to be a fountain of manufacturing jobs from that alone. You know, modern car factories will look like very automated Tesla factories with a small number of people and a large number of robots. That's a future we can't hide from, and what we need to do is to be the best in the world at designing and programming those robots. And that's that is the future of manufacturing, and you should not think otherwise. Anyway, but it's really important that the other advantage that we should preserve is just manufacturing techniques. You know, we invented an numerically controlled machine, milling machine, back in I think 1950, the first. And so I don't know how many of you have programmed in G code. Do you know what that? Okay, all right. I am probably the only member of Congress who programs artificial intelligence and blockchain and a number of other things, but also G code. For many years, my first stop at the national laboratory that I worked at was the machine shop. And I found that I could really get parts out of the machine shop fast if I would program them myself. And so I just did that to get stuff really fast. And so anyway, it's really important that Congress hear from it. So thank you all, and on behalf of 50% of the chairmanship of the R&D caucus.
Thank you.
Thank you, sir.
Thank you, Congressman Bill Foster. We really appreciate your support of advanced manufacturing and federal investments in research and development, and we look forward to working with you in the future. Thank you. Thank you again, Congressman. It is now my pleasure to introduce Brian Paul, who is Professor of Manufacturing Engineering at Oregon State University, who will be moderating the discussion for our first panel. Again, the bios are in your handout, so we will keep the introductions brief. Brian.
Good afternoon, everyone. Just thank you. I just wanted to say thanks to ASME for putting on a great event like this, give us an opportunity to talk about some of the great things that are going on inside Manufacturing USA, and just for you all being here to receive that. So just a little bit about the format as we go forward here this afternoon. So to my right, to your left, is a panel that's going to be talking about education, workforce development, things going on inside Manufacturing USA institutes. several institutes be identified in the course of that. And then to my left is a panel that is going to be talking about technology development aspects of the Manufacturing USA Institutes. And so I guess my role, as well as Robin's role here, will be to kind of facilitate that. And I want to kind of kick that off, maybe talking about a few statistics. So the manufacturing workforce in the U.S. is currently about 12.8 million workers. And they have, they have a lot of really well-paying jobs, rewarding kinds of careers and those kinds of things. Statistics that I got ahead of time in terms of wages and benefits are well above average for manufacturing workers. And this is according to a couple of the different bureaus inside the U.S. government. So it sounds pretty good, right? Higher wages and better compensation in general for those 12.8 million. We've made workforce development a tenet, one of the two key tenets of the Manufacturing USA Institutes. And so there's the question, why? And the answer is pretty simple, because currently, industry really struggles with trying to fill a lot of open jobs that are available within the manufacturing industry. And so that's mainly a skills issue. And further, if you start to look at the future, you've got entities like Deloitte and National Association of Manufacturers who put reports together that suggest something like 4.6 million new manufacturing jobs in the next decade. What goes along with that is more than 50% of those are projected to not be filled for the same skills gap kind of a reason. Now, I'm an educator, so I work at a university. And the question I could ask, or you could ask me, is, well, why don't you put the curriculum together to go off and fill all those gaps and those sorts of things? And, there's a couple of thoughts. As an educator, I don't have access to a lot of manufacturing industry, right? I've got my job, I do my things in one part of Oregon, and we've got manufacturers all over the state. And so educators have difficulty accessing manufacturers at that level to be able to understand what some of those needs are. And further, the fast pace of change in manufacturing industry, right? So we're turning over jobs, and there's new skills. And when we start to think about the technology development that has to go on to be able to keep our companies competitive, that just by default, there are manufacturing technologies we don't know of yet. So we can't build curricula around those. And that's where the Manufacturing USA Institute really come in and become very valuable for us, because it's a convening environment. It's an environment in which members, right, companies, but certainly universities, community colleges, 501c3s, all these entities can come together and exchange in various ways through different kinds of project activities and stuff that are going on. So I've been able to kind of see that up close and personal. I'm a module manufacturing focus area lead for the RAPID Institute. So RAPID's focus is on the chemical process industry. The idea is to move what's called modular chemical process intensification into application, which largely is not. The proposition there is cheaper chemical manufacturing plants and lower energy kind of usage and those sorts of things. A lot of good things that we want to do in that institute. Last week, I piloted, along with a colleague of mine, boot camp. So what we do in boot camp, we break them down, we build them back up. So over 4 days, we brought in industry folk who were interested in learning about modular chemical process intensification, taught them what that was so they could take those skills and those capabilities back and begin to move that technology and those outcomes forward in their industries. The thing that would go along with that, though, is that I saw a network. I saw small and medium-sized as well as large manufacturers exchanging and interacting in that room. And you need that kind of a network and that kind of a village to be able to move those kinds of technologies forward. So that's part of what this is about. So certainly inside the institutes, there's not just a technology development role, there's also a workforce development role. And it's because that we're working on these new technologies, they don't exist yet, but having all these community colleges, universities, in close proximity allows us to be able to pull together a lot of the curricula and close that skills gap. And so I think that maybe sometimes might be overlooked a little bit in overall, if we're going to move to get full manufacturing technology forward. I think the congressman mentioned the need, right, to be able to have people to program the robots and some of the advanced technology going forward in the future. Okay, so just to kind of get us going here, just how have we been doing? So in the chairs in front of you, or when you sat down, the annual report for the Manufacturing USA Institute from 2018 is there. One of the statistics inside that is there were about 205,000, more than 205,000 folks trained or retrained inside the institutes this year. If you look at the kinds of folks that were retrained or trained, you're talking vets, you're talking students in existing programs certainly, but also workers on the line that need some of those retraining and to close some of those skill gaps and stuff. So that's a lot of people that have been affected, and I think what our panel's job here is to begin to unpack that number a little bit, right? So to talk about some of those experiences here. And so we have with us 3 distinguished panelists that are going to help tell that story. So first, Dr. Robert Smith, who's a technical fellow within Boeing. And next to him is Helena Fruscio. I'm sorry, Elaine for botching, Fruscio. Altsman, so she can pronounce her middle name better than me. She's an assistant secretary within the Executive Office of Housing and Economic Development in the state of Massachusetts, the Commonwealth of Massachusetts. And next to her, actually on the far end, is Matt Plummer, who's the Director of Operations and Environmental Health and Safety for Sun King Incorporated, who's an electronics equipment recycler. And so he's got some perspectives from the Remade Institute. So to kind of get us started here, I think what we'll do is have Dr. Smith, in his role as a technical fellow within Boeing, kind of talk about some of the activities that he's been involved with from engineering or education workforce development perspective, and describe some of those ongoing efforts to train people not only in how to innovate, but also how to think about moving it forward in the market and entrepreneurship. So we don't necessarily tie manufacturing and entrepreneurship together, but if you're going to move products forward into the market, you've got to figure out how to make them. And so I think he's got some exciting insights and perspectives from that perspective. So let's welcome Robert.
I should go to the podium. All right. Can you hear me?
Yes.
All right. Get this thing right in my face. Okay. Good afternoon. Like I was introduced, I'm Dr. Robert Smith, representing the Boeing Company and our workforce development efforts that have been in collaboration with the Advanced Manufacturing Institutes. Now, more specifically, I'm going to talk about activity that I have been experiencing with the NextFlex Consortium and a program called FlexFactor. The NextFlex Advanced Manufacturing Institute is maturing additive manufacturing for electronic systems to enable flexible hybrid electronic devices and applications. Now, flexible hybrid electronics are bendable, twistable, conformable, and small systems that enable seamless integration of electronic systems for human monitoring, platform health, and data analytics enablement. So what we do in the Institute is we take these kinds of things and turn them into these kinds of things. So that's an enabling manufacturing capability that's being developed in the U.S. to be able to print electronics on demand for different applications and enable new ways to do technology in lots of different applications. So Boeing has been engaged with Nextflex to provide workforce development in Alabama with expansion into South Carolina, Louisiana, Texas, and Washington State. So we're moving this Nextflex Flex Factor program across the United States, and I'll explain to you what that is. The Flex Factor program was developed in California, which is the hub of the Nextflex Consortium. I'm going to tell you about 4 meaningful deployments that I've been personally involved with. A high school STEM application, a veterans program in association with the Alabama National Guard, an industry partner awareness program, and a university engagement effort. So first let me explain what the Flex Factor program is and how it goes beyond experiential learning. It's a 6-week program that requires students to develop their own product concept and mature a business plan that is defended at a panel presentation. So it's kind of like Shark Tank, but without money offers. Uniquely, the program starts by emphasizing skills like proper dress, punctuality, and preparedness for job interviews. That's a new thing for a lot of kids in high school here. It exposes students to industry partner facilities and research labs where they see real manufacturing tools and real applications being developed, as well as facilities at local colleges. The outcome of the program is to excite the students about manufacturing and show them education pathways that include both community college and university programs. Now, Boeing works with community colleges across the country to provide certificate programs that are relevant to the workforce. These programs have been a great success for Boeing and for the employees. The fact that the Flex Factor program shows a 2-year pathway made the program very attractive to us. Additive manufacturing uses unique tools and operators that have diverse knowledge of mechanics, electronics, robotics, computer-aided design, digital design, and software coding are highly desirable. These skills can be obtained and refined through a 2-year program where we can employ a student on a learn and earn program where they can work while they're getting their certificate. Now, once they graduate, we can hire them full-time, and then they can think about pursuing a 4-year degree if that is meaningful to them. So we end up having a viable workforce contributor, and they decide if they want to do more. We see that as a win-win situation for the company and the employee. So first I'm going to tell you about Nalani Hogue, who is a 10th grader from Hazel Green, Alabama. She participated in our spring 2019 STEM program. On the first day, Nalani was interested in the arts. She had very little interest in the Flex Factor program. However, after the Boeing tour, she became very interested in engineering after seeing the technology and the products that were being developed. So Nalani's quote at the end of the program was, "I noticed there were different types of engineers in different fields to being an engineer, and it opened up my mind to help me realize what I can do in my future." So I have a video of Nalani if anybody wants to see it afterwards. In August, we completed our first Veteran Flex Factor event, also in North Alabama. This event was executed in a week and emphasized transitioning of learned skills to advanced manufacturing jobs. In this instance, I'd like to highlight 2 individuals, Technical Sergeant James York and Sergeant Alyssa Christian. Technical Sergeant York said, "This program has helped me understand the options out there, and I could be successful. Before going through Flex Factor, I did not think I was hireable or had value in the private sector. It has inspired me and given me hope. I did not know that I had options like this." Sergeant Christian's aha moment was during the Boeing tour, where she saw her former group leader working in the missile production facility. That's when she realized her skills were transferable, and that Flex Factor showed a pathway to a future she did not realize. More importantly, the program did not show a way out of the National Guard. It shows a path for personal growth and skill transition that allows retention of guardsmen. and that was a key factor that the National Guard was looking for. Another win-win scenario. So the work of the manufacturing institutes is so new that many in industry and government are not fully aware of the benefits. So to address that audience, Boeing deployed the Flex Pro version of FlexFactor at our Next Flex workshop in Seattle. Flex Pro is a 2-day accelerated professional development event targeted at technical and programmer leaders to heighten awareness. You'll go through the same things, develop a product concept, develop a business plan, and pitch your idea to the other folks that are part of the event. If you have an opportunity to attend a Flex Pro event, you would find it very amazing. And so if some of you hear about that, take advantage of it. Lastly, in my current role, I am Boeing's Distinguished Professor of Practice for the Calhoun Discovery Program that is being developed at Virginia Tech. Boeing is collaborating with Virginia Tech to develop a transdisciplinary learning approach that brings together students from multiple colleges within the university to investigate problem sets of industry interest that can have societal impact. We believe this approach will produce innovative thinking leaders of tomorrow. As part of the curriculum, each student performs an individual development project. NextFlex is providing Flex Arduinos, these little things right here, to be used by the students to prototype real-world products and concept architectures as part of their education this year. All of this was possible by accessing a part of the $100 million that Boeing dedicated to workforce development in 2018. Boeing is a member of 6 of the DoD-aligned manufacturing institutes, and each has a different workforce development approach. Where appropriate, Boeing has leveraged the results of our engagements with those institutes' workforce development efforts to produce internal workforce training, which has been a real advantage for us. However, unique to electronics additive manufacturing, I have found our involvement with NextFlex and the FlexFactor program to be very rewarding and broadly applicable. Thank you.
Thank you, Robert. So our next panelist is Helena Fruzio-Altsman, and I mentioned earlier that she works in the Office of Housing and Economic Development in the Commonwealth of Massachusetts. And so she's going to talk a little bit about some of the Manufacturing USA investments that have been made in the state of Massachusetts and some of the innovations in workforce development training going on in her state. So please welcome Helena.
Good afternoon, everyone. As it was mentioned, my name is Helena Fruzio-Altsman. I am an Assistant Secretary at the Executive Office of Housing and Economic Development at the Commonwealth of Massachusetts. Over the last 4 years, I've had the responsibility, but also, I have to say, the pleasure of implementing our manufacturing strategy on behalf of the Commonwealth. So we've had a long history of manufacturing in Massachusetts, dating all the way back to the Industrial Revolution, you know, textiles in Lowell, wire making in Worcester. We have a long history. Those were advanced technologies and advanced manufacturing in its time. And today we take it very seriously that that is part of our history, but also part of our present. How we do that is a couple of ways, but the first way is our nation-leading investment in the Manufacturing USA Institute. This is a $93 million investment that the Baker-Polito administration has made in Manufacturing USA. We do invest in 4 of the Manufacturing DoD institutes, Manufacturing USA institutes. First is the one that is actually headquartered in our state of FOA, or Advanced Functional Fabrics of America, for the future of textiles. But we also invest in NextFlex for obviously flexible electronics, also AIM Photonics for integrated photonics, and finally ARM Robotics. We are about halfway through that $93 million investment, so we just crested over $50 million of commitments through our program that we call the Massachusetts Manufacturing Innovation Initiative. Because we like acronyms, we just call it the M2I2 initiative. So that is how we co-invest with the Manufacturing USA Institutes in Massachusetts. We do make investments just within our state borders, but we make investments in both technology and in workforce development. I will be only focusing on our workforce investments here today, but please know that we have a big portfolio in both of those types of investments. So, in addition to this, the M2I2 program, we also are running what I'm going to call our classic manufacturing training system. I am betting that many of the other states have this, which is, this is our fully coordinated, we're very excited to launch this fully coordinated system last year, but this is the system in which employers and workforce engage with our VOCTECs, our community colleges, our universities. We have hundreds of partners across the state, and every single year we are training both incumbent workforce, we're upskilling them, as well as new entrants into manufacturing fields. But CNC programmers, machinists, that's really the focus, and we are training hundreds of people every year. In the first term, it was thousands. The first Baker-Polito administration term, it was thousands of people that we are training, many of whom already have a job before we hand them their certificate. These people are in high demand. We're very much proud of this system, but I have to talk about a challenge in that system. And that challenge is that we are training for the jobs that are in demand today. And that demand is massive. These manufacturers, when we are talking to them, the number one thing they say to us every time we talk about, we need workforce, we need workforce, we need this, we just need more people. And so we have our head down solving that issue every single day. But focusing on today clouds the bigger picture that we see on the horizon. And that is that manufacturing is changing, and it's changing quickly, and those changes are not going to stop. Those changes are driven by technology, the convergence of technologies. This is changing not only our tools, but our processes and our communications networks, all embedded in every single manufacturer in Massachusetts. These changes don't just affect some, it literally affects all if they want to be globally competitive, and they all have to be globally competitive. These changes also are high-performing sensors. It includes our massive change in how our computing power is just unparalleled, data storage, communication systems, all of this these manufacturers have to keep up with every single day. And that's really hard if you're a small manufacturer. And so that is not only affecting the manufacturers themselves, but the workforce within them. And then if the workforce has to pivot and be up on the futuristic new skills, guess what? So does our classic training system. So, whether or not it's robotics or machine learning, our system, our VOCTECs, our community colleges, the people who are, teaching the curriculum are coming up with the curriculum or teaching it, all need to be moving at this pace. And quite frankly, those changes in some ways are just unknown and they're hard to predict. This is the point where Manufacturing USA Institutes came in with their cape or their crystal ball, however you want to put it, and they gave us the roadmap. So what we have done in Massachusetts is we have worked with these Manufacturing USA Institutes to not only see that roadmap that they lay out for us, but start to walk those roads along with them. I would like to just highlight, I think this is easier to grasp if you talk about an example. So I'm just going to talk about one. Please note this is only one of many, but I did want to just highlight an investment that we've made. So one of the investments we've made is through the DoD Manufacturing USA Institute ARM Robotics. It's about a $2 million grant, so put that in perspective of the $50 million we've committed, right? So $2 million. It is leveraging additional $3.5 million from other partners, including ARM. It brings together MIT and Mass Robotics, but also other OEMs and other robotics companies. And this project is what we call TeachBot. So what TeachBot is addressing is the fact that, one, we have a shortage of manufacturing roboticists in Massachusetts, and two, even if we wanted to just be like, yay, let's open courses and teach people how to work with robots, we don't even have the instructors to do that at a scale that we need it to happen. So TeachBot is a tabletop robot, completely movable, it's tabletop. It is a demonstration machine, but also an instructor. It is a robot that teaches people how to work with robots. Like, so cool, right? Anyway, this robot is, we have been in development of this robot for 3 years. Last year, we're in beta test at Benjamin Franklin Institute of Technology. We just can't wait to get it out into this classic system. We couldn't have done this without the structure, the advice, the crystal ball of these Manufacturing USA institutes. They have been a vital partner, and that roadmap that we are walking together is important on both the technology development side as well as the workforce side. So I don't think I'm over, but just final thoughts. So I work for economic development. Manufacturing is such an important part of our economy in Massachusetts, as it is for the whole nation. I just know the the Massachusetts version of that story. We have just small manufacturers. They are such an important part of what we are doing. And our partnership, and as we are rolling out this strategy, working with the Manufacturing USA Institutes, I just highlighted the workforce angle of what we're doing, but really we are pivoting industries here. And this discussion usually takes decades. The institutes are changing that discussion from decades to years. We are 4 years into this. In Massachusetts, we are mid-stride in implementing these investments, so we still have a lot more to do, and we are excited to be doing that work. And obviously, we just feel like there's a new frontier that we are just cresting into. 4 years is not all that long of a time when you're starting to talk about industries. So maybe just because it's my daughter Penelope's birthday tomorrow, she's 2, I am just sort of reflecting on, like, my hope for her is that when she is ready to get a job, that one of those jobs that she wants and all of her friends wants and that they're competing for is a manufacturing job. And these jobs that the Manufacturing USA Institutes are helping drive us towards are those jobs. And so we're grappling with this. We're in it in Massachusetts. So I am so thankful to be asked to speak today. I truly believe in the work that we are doing collectively, and happy to answer any questions.
So last but not least, we have Matt Plummer, who's Director of Operations and Environment, Health and Safety for Sun King Incorporated. I mentioned a little bit earlier, electronics recycler, working with Remade. So we'll give the time to Matt. Let's welcome him.
So again, like you said, my name is Matthew Plummer. I'm representing Sun King Incorporated. We are a small, medium-sized enterprise located in upstate New York. We recycle approximately 25 million pounds of e-scrap annually. We have about 100 employees. I've been in business coming up on 20 years. We've been a member of the Remade Institute since its inception several years ago. Currently, we're working on several projects with National Laboratory and several different universities, which would never been a possibility if it wasn't for the Remade Institute. These projects focus on the logistics of e-scrap movement from collection until end-of-life processing, to looking for more efficient and better ways to recover some of those recyclable materials. Sun King chose to join Remade because it focuses on advancing the circular economy. Another big advantage for Sun King is that the headquarters for Remade is located nearby at the Rochester Institute of Technology, which is right in our backyard, so it was a no-brainer there. Being a local industry member really gave us great access to the people and companies that are very involved in advancing Remade's mission. When I was approached about joining the Remade's Education and Steering Committee, it was something I did not hesitate to be a part of. Compared to other institutes, Remade is, I think, still in the beginning stages of creating content and programs. Like some of the other panelists had mentioned, are already kind of up and running. So I kind of had the opportunity to help, have input into those programs. which is one of the reasons why I wanted to do it. One of the first things we did was survey remade members to see where the gaps were with the current labor force. Also, I can tell you that the feedback that I personally provided and that Sun King provided has already been incorporated into the programs that we're working on today, and included in the Education Workforce Development Roadmap. So specifically, much of our current workforce comes in without much industry experience or even basic understanding of the material types that they're working with, and now we're trying to recover. And Remade's already have been able to offer excellent and free webinar programs on topics such as metals and plastics. And the webinars have been greatly attended. Had participation over 55% from industry. In addition to the member interviews that I referenced before, we've created a workforce profile study to better analyze the current labor pool. We've reviewed curricula at colleges and trade organizations to see what's currently available, of course, as to not duplicate efforts. From there, a strategy was developed to endeavor to provide programs and content to Remade member organizations. In addition to the webinars currently being offered, Remade is working on short course workshops that would ideally be in the 3 to 4 hour range about a specific topic. Conceptually, the goal is to be able to stack these workshops into a tangible certification program that employees can achieve. Personally, continuing education is something I consider when evaluating compensation and opportunities at an organization, and it would be great to offer, these programs to the people that I work with or work with under me, through our membership with Remade. Last, I want to discuss how employment workforce development within Remade can help address challenges that I see approaching in the electronics industry. Like many industries, e-scrap recycling is constantly changing. I've been shown an example of that just here sitting next to Robert with a flexible circuit board. So it kind of is a perfect example here. I'd like to check that out because at the end of the, down the road, eventually those kind of materials are going to end up in our facilities. What we were doing in the past or the present is it's going to be different in the future, where we might have more just looking for metals recovery or plastics recovery, things like that we can recover, get to a form that we can put back into new manufacturing. Doesn't look to be a lot of gold or copper or silver or some of those other precious metals on those boards, so we might have to look at more component recovery as opposed to just materials recovery, look for more reuse opportunities. So in the past, where a large hammer and a screwdriver was the more appropriate way to dismantle some of these materials and get to that stuff, we're going to need to be more technical and have better tools or robots, and have people that need to know how to maintain those robots, program those robots, use those tools, use those large pieces of equipment to have better recovery. So essentially, brute force is no longer the best practice. Our workforce is going to need training of greater skill to be able to locate and remove hazardous material, such as batteries. Lithium polymer batteries are not inherently strong on the outside. They're very soft, and if you puncture one by mistake, you will definitely have as we call in the industry, a thermal event on your hand. Thermal event. So this is where I can see, employment workforce development, Remade, and Manufacturing USA as a whole, as I learn more about some of the other institutes being here today, that can really help fill a gap for us. By providing that specific course workshop, like I mentioned earlier, but also getting access to new technologies that otherwise we may not be available to us, into a smaller company like Sun King. As Remain's work in education and workforce development continues to progress, we will certainly be involved to not only take advantage of those opportunities provided, but to continue to participate in its development as well. Thank you.
Okay, so it's our intent to allow the audience to ask some questions. So if you've got any questions, feel free to kind of dial that up. We'll take 2 or 3 questions here and then move to the next panel. So maybe kind of get some things kicked off here a little bit. So Robert, can you describe how Flex Factor or other institute workforce efforts have been helpful in training and strengthening the supply chain?
So, I think something I could say right now sort of echoes what you heard from these guys. In our experience, what we're doing now, trying to do additive manufacturing with electronics, which is different than additive manufacturing with metals, there's just not a workforce out there. So we're bringing in 4-year degree engineers, and putting them in our lab and putting them to work, and they're having to learn in real time, OJT, how to run the tools, what to do. That's what their time is being spent on instead of doing some other things that could be more innovative. So we need 2-year programs out there to really get some technician level people spun up. We're helping to define the curriculum right now with the community colleges that really goes beyond what metals additive manufacturing does. It looks at the different components that you need that I mentioned for doing the electronic side. And how that hits the supply chain is we're looking at doing some things ourselves right now because we're maturing capability and maturing some technology. But we need to be able to have a supply chain that can do the same thing. And the smalls don't have the luxury of really bringing in 4-year degree people to do some things. They really need people to attack that right now, which would be part of having a 2-year program that can get people in the right frame of mind and have the capability there to do these advanced things, which are in demand right now. It is amazing that when you talk about some of the numbers of how many open jobs there are and that you can't fill half of them. And we have that experience today. So it's difficult for us to really move. We would like to do ubiquitous implementation of some of these technology developments. There's not a supply chain support. So maturing all these things, workforce development, using institutes to help make that happen and advance it is critical to producing the supply chain that helps this stuff become a real product and a real manufacturing activity in the future.
So any other questions from the audience? I think what we'll do is we'll move on to our second panel. So that is being led by Robin Hardin-Pate, who is the Chief Operating Officer for ACME, the Composites Institute. So let's welcome Robin.
Thank you, Brian, and thank you, panelists. Also, thank you so much for having us, ASME. We're so thankful to be here and have the opportunity to tell our story. As Brian mentioned, the first two panels you'll hear from today, and then you'll hear Q&A remarks, will be workforce development and then technology development. And our panel will talk a lot more about some of the technology that the institutes have helped enable and develop. And hopefully, whenever Penelope is looking for a job one day when she's 20 or 30, these technologies will...
Sooner than that, please.
Sooner, yes. These technologies will help pave the way for her future career paths and those of her friends. So in my role as Chief Operating Officer with the Composites Institute, I've seen firsthand the impact of the technical research and development collaborations. These relationships are helping to better develop and connect the supply chain ecosystems and de-risk the innovation investments from private industry. This connectivity is resulting in unique opportunities, enabling manufacturers to gain new learnings and ultimately manufacture products with more efficient processes and better materials than ever before. And this is important. This is important to the United States, and here's why. A strong U.S. manufacturing sector is essential to our economy and national security. Manufacturing in the United States represents more than 60% of private sector R&D, more than any other sector. American manufacturers contribute more than 2.3 trillion, with the T, dollars to the U.S. economy. Taken alone, manufacturing in the U.S. would be the 8th largest economy in the world. The 2018 National Strategic Plan for Advanced Manufacturing establishes a goal of leveraging public-private partnerships to develop advanced manufacturing technologies and transition them to market. This is also helpful in training a skilled workforce and maintaining a strong manufacturing and defense industrial supply chain. Manufacturing USA institutes work tirelessly to achieve these goals. Federal support for the institutes creates a framework that enables industry, educational organizations, and federal labs to work together and take the most promising new technologies and transition them to be manufactured in America. This is making sure that whatever is invented here is made here, and this is really important. In fiscal year 2018, the institutes collectively leveraged more than $183 million in federal funds, matched by $304 million in state and private investments. This is really important because we want to make sure that people understand industry is fully involved. They are very engaged in the work we're doing. Collectively, this resulted in 476 major collaborative research and workforce projects, and this engaged 1,900 members across the country. This is also an increase of 74% versus last year. So if we take a minute to stop and think about this, last year we had similar panels in Rayburn, and we were talking about some of the impact of some of the projects, 74% more than last year. That's huge. So as institutes, we only received our funding at a small period of time ago. We're all in different points with our cooperative agreements. But when you think about it, if we have 5 years of funding and we're just now in our peak right now, if you will, there's a lot more to do. So we have a lot of successes to talk about, and we'll talk more about those in a minute. But there's more to do, and we want to partner with you all to do that. So before I turn it over to our esteemed panelists, I want to share a few technical success highlights. You can also find featured in your 2018 Manufacturing USA Annual Report that will also be available at the expo tonight. AFOA, a DoD-sponsored Fibers and Fabric Institute, is working on a System in a Fiber project, which is directed at producing fibers with individually controllable and addressable devices. LIFT, a DoD-sponsored institute, also co-located with IATME's Scale-Up Vehicle Research Facility in Detroit, Michigan, is leading a project that will reduce Humvee rollovers by 74%, reducing fatalities of service personnel. This is impactful. And at my home institute, IATME, we're working hand in hand with Local Motors, a national technology company who recently built its innovation facility a mile from our headquarters in Tennessee. The company just installed the world's largest 3D printer at its microfactory and is working closely with IATME, Oak Ridge National Laboratory, and many others to produce Ollie 2.0, one of the first self-driving vehicles commercially available. So more to come on those. It's inspiring to see individual passions in our members collectively impacting the world around us. I'd like to introduce you to our 3 panels who will offer broad and deep perspectives regarding their individual and collective experiences with the Manufacturing USA Institutes. Before I do want to say thank you to a few other leaders in the room. Thank you, Valerie Leitner from the Department of Energy, for being here and for your support. Mike Molnar, thank you so much for your support from NIST. And Tracy Frost, thank you so much for the DoD support. Our institutes are better because of your leadership, and we thank you. Also want to thank IATME CEO, John Hopkins, in the audience. So he is here, he is their technology expert and many other things, and he will be at the expo. So ask him the really hard questions. Without further ado, I want to make sure I introduce our panelists, and so they have plenty of time to tell their stories. To my left, I have Tom Dry, who is with Techmer PM. He is a vice president. Also have Jeff Wilcox, who is with Lockheed Martin Corporation, also vice president, and Dean Bartles. And Dean is president and CEO of the National Center for Defense Manufacturing and Machining. After the panelists share their story, we'll have an opportunity for Q&A. So please be thinking about the questions you have, and we'll make sure we have time to answer those. We'll be concluding this event at 5:55, so we'll stay on track there. Okay? So Tom, I'd like to hand it over to you for a quick introduction. We'll do quick introductions and then we'll tell our stories. Just introduction for right now, so just
Okay.
a minute or two, and then we'll go into your stories next.
All right. So I'm Tom Dry. I'm with Techmer PM, and our company is, we're in plastics, and we're custom compounders. What that means is we take resin and we add all kinds of things to it, whether it be carbon fiber, glass fiber, all kinds of additives, colorants, lubricants, conductive aids, et cetera, just all kinds of things to make a special end effect. And we literally make thousands of different products all the time. And if they can do it in plastic, where they're doing it, and we're custom guys.
Thank you, Tom. It's really hard to talk about this in 1 to 2 minutes, but I'll do what I can just to introduce the subject. So Jeff Wilcox with Lockheed Martin. Really proud to say on behalf of Lockheed Martin, 105,000 people, we've been in this since the beginning. Going back really close to 10 years to some of the early studies like the MIT Pi study and some of the early AMP work that led to the creation of the institutes. We dove all in. We were members of the first 7. We're now a member of 8, so strongly committed to this. We've also been up here on the Hill many times, like in support of ramming, to bring all this into statute so that we can ensure the scalability and sustainability of this network. We're here for many reasons, and I'll cover that, I think, during Q&A, but I think just the broad outline I'd like to leave you with is Lockheed Martin is fundamentally a system integrator, not so much a manufacturer, although we do some of that. As a system integrator, stewardship of the supply chain and a robust supply chain is really job one for us. Our job is to bring the best of breed in American manufacturing into our systems for our customers. And this community, this village, this family has been a big part of that.
So I think everybody can hear me without the microphone. Am I correct? Can you hear me in the back? So I'm Dean Bartles. I'm the CEO of the National Center for Defense Manufacturing and Machining. And we're a small not-for-profit located in Blairsville, Pennsylvania. We run multiple programs in partnership with DoD. We find problems and help them find solutions, and we work with alliance partners to do that. One of the programs that we run is the American Mix program, which is the National Additive Manufacturing Innovation Institute. John Wozinski's here. He's our executive director, so at the expo this evening, you can ask him all the hard questions. But very happy to be here and very, very, very enthusiastic about what the U.S. government's doing with these manufacturing institutes. It's a great program, and we hope that you agree. Thanks.
Thank you. Now we'll get into your stories. Jeff, let's start with you. You're a representative from Lockheed Martin. You guys are a member of 7, now 8 institutes. So tell us why you joined and tell us a little bit more about your story.
Yeah, boy, why? So, largely when you look at the breadth of our mission, our customers' mission, it really calls for bringing together all of these technologies that you've been hearing about. There's nothing that doesn't touch national security when it comes to the technologies, whether it's composites or metals or digital manufacturing, robotics, and so forth. So we joined, all 8, partly just because of the breadth of what we do and the importance of investing in those. It also really helped us structurally to pull together our research roadmaps in those areas by coming alongside these institutes. And one of the great things about the institutes is their power to convene. They bring together government and industry and academia and industry of all sizes. And there aren't a lot of places that I go in my job where we can have that conversation, create that space to foster that dialogue. So that's why we joined all 8. I would say the national network aspect of it is very important to us. When you look at Industry 4.0 holistically, or digital transformation, which is my job and title now, that is sort of a nonlinear, holistic combination of all these technologies we're talking about. It doesn't make sense to have individual roadmaps, for composites and metals and robotics and digital engineering and so forth, because this is one narrative, this is one story, all pushing forward American competitiveness for security and prosperity. So that was the other reason. And as I said, really for us, as an early architect of our engagement, being able to come alongside small and medium-sized enterprises who we may not get to meet in the course of daily life. When you're producing at such a high rate, there's not a lot of spare bandwidth, to go exploring for new suppliers and new capabilities. So being able to go to those 8 different institutes and have that conversation. I would also point out, one of the great things about them has been, since it's important to us that the small and medium-sized enterprises are there. The joint approach with NIST and the institutes and the MEP program in particular, the MEP embeds, which we can talk more about, but that has been a mechanism in the channel that has allowed the institutes to reach out broadly. So that's a great whole of government approach that has really worked very, very effectively from our perspective in terms of just bringing a lot of fascinating, U.S. capabilities to the table.
Thank you, Jeff. Dean, can we hear from you? Let's hear your story. You've been involved in a number of institutes as well.
Sure. So I have had the pleasure of being involved in more than one institute. Some of my friends in the room find that humorous, but it's really been a great honor. So I started off, and my first one was the Digital Manufacturing and Design Innovation Institute in Chicago, which is now called MXD. Shout out to my great friend Chandra here, who's now running that organization. And let me just tell you a little bit about how when we first launched, how we got the small companies involved with the technology development. Very, very critical piece of each one of these institutes. So, these institutes are consortiums. They're made up of companies and academic partners, and state and local governments are involved as well. And of course, our partner with DoD in case of our institute. And we formed this consortium by getting companies to join. Certainly, my friend here from Lockheed Martin was one of our first platinum members, and we had about 6, I think, platinum at the time, and 6 of the tier 2s. But we had a lot of small, medium-sized companies. I think altogether, back when I left, Chandra, was around 300 plus members, and a significant portion of those were small companies. So how do you get these small companies engaged, right? So what we would do is, the members would get together in our technical advisory group, and they would talk about, where's the technology stand today? Digital manufacturing. Does everyone even understand what that means, right? So it's a confusing term. Digital manufacturing, think about being able to replicate your entire manufacturing process virtually before you ever go out to the floor and set up a single machine or cut a single chip. The entire process is operated virtually, and you can figure out a lot of problems before you actually start your production, and that can really expedite, make things go faster once you get started for a lot less money, right? So we would form this technical advisory group, and we'd figure out, here's where that technology stands today, here's where we think it's going to be 5 years from now. Here's where we think it's going to be 10 years from now. Okay, what research can we do to advance the maturity of that technology and get it into the hands of the small, mediums, as well as the large corporations who are out there making products for the Department of Defense, as well as commercial products? So we'd decide on what those project calls would be. We'd have a project call and announce, hey, we want to do research on X, and then we would have a workshop. And I'm telling you, this was one of the most fun days we would ever have. We'd have a workshop about one of these RFPs, and we would get about 200 companies, members to come. A lot of them were small companies. And most people there didn't have any idea what these small companies even did. So what we would allow each company to do is we'd give them 60 seconds and 1 PowerPoint slide if they wanted to do it. And I'm telling you, over 100, every time we had a workshop, would line up. And they would stand up there for 1 minute with 1 slide and talk about, here's what we do. Here's why we're interested in this project call. Here's the technology solution that we can bring to this problem. And companies like Lockheed Martin, who had people in the room, and Caterpillar and John Deere and Rolls-Royce, etc., boy, those guys were listening. And then at the breaks, you would see the teams form to work on these research projects. So usually a typical team would be a large corporation, a couple of small guys, maybe an academic partner, and that's how this interaction of this ecosystem develops. That's, I think, the fundamental part of these institutes is the ecosystems that are developed around these technology spaces, and that allows the small companies to meet these large companies and to provide solutions that, frankly, the large corporations couldn't provide without them. We've even seen some of the small companies be acquired after a couple of years working with a large company because they did have a really specialty niche technology. So I can't emphasize enough the small companies that are the backbone of all of our manufacturing here in this country, being involved in these institutes, and the institute models are set up for that to happen. I do obviously need to talk about America Makes because I'm with that company today. So, but America Makes, we're focused on additive manufacturing, right? So additive manufacturing, everybody knows what that is, right? I don't think so. I think a lot of people think about, oh yeah, you guys make those little plastic parts for prototypes so that the engineers can, touch and feel what they look like and help them visualize better. No. It's going way beyond that. So now they're making additive parts in metal, right? So you're 3D printing parts in metal with metal dust. You're hitting it with a laser. That's just one of the technologies. John could talk about a lot of them, right? But imagine being able to grow a part from nothing using powder. It's pretty fascinating technology. General Electric's invested $2.5 billion in this technology. They're making engines now that used to have over 900 parts for like less than 10 parts, because you can 3D print components inside of components that turn, and it's fascinating technology, and we've got lots of small companies that are involved in that space, and some of those have also been acquired by large corporations, like General Electric is one example. So these consortiums and these ecosystems are critical to the future of the supply chain, and I'm very excited to be a part of it, and I hope all of you embrace it as well. Thanks.
Thank you, Dean. And now let's hear from Tom Drive.
Yeah, thanks. Appreciate it. So, let me talk again about plastics. My area is plastics, and so talk about 3D printing, additive manufacturing in particular. We're doing plastics for a long time, as has been kind of pointed out here. But what we have been doing for a long time is large part additive manufacturing. So you probably saw, everybody's probably seen the small desktop, tabletop type printers. We're talking massive printers now, printers that would not fit in this room. Very large printers. I just left hour outside New York City just this week. I was up there looking at some printers up there that are no longer on the desktop. In fact, this printer is sitting out in the woods. It's sitting in the middle of Garrison, New York. Everybody's familiar with Garrison, New York. They're in print a house there in New York, out in the woods. So we've got a truckload, literally a truckload of material sitting out in the middle of the woods, covered by tarp. There's some expensive hundreds of thousands of dollars of machinery sitting there in the middle of nowhere overlooking the Hudson River. And by the end of the year, probably first quarter next year, you'll see a house sitting there, a 3D printed house. It's going to be very similar to, if anybody has seen the 3D printed competition or the additive competition held by NASA just a few months ago, and a customer that we're working with called Space Factory. You can Google it. Very fascinating company. But they took first place using our materials, very innovative material that we came up with for this Mars habitat, which is going to someday hopefully put astronauts living on Mars. But to do that, how do you do that? You've got to have habitat for them. So the concept is to additively 3D print autonomously on Mars. So very high tech, a lot of science, a lot of research going into this, but very real, I think, is going to happen. So that's just one avenue. So we are, again, the specialty plastics people dealing with a lot of different customers, and look at the USA, the competitive nature of our manufacturing. When it comes to plastic, let's say, mature industry plastics, every now and then you get kind of a kickstart into what's next, what's coming down the road. Well, I just described, a 3D autonomously printing houses is one of those things. And we're getting our workforce internally excited, because all we make are pellets. We ship pellets out the door, either injection molded, or in this case, additively manufactured. And we're working with some really interesting OEMs. And the IACME Institute has been a great conduit to allow us, we're a medium-sized enterprise, let's say we're roughly 650 employees. And for us to get an audience with people like Lockheed Martin or Boeing over here, or other, I don't know if large OEM is the right term, the adjective to say you guys, but maybe huge OEMs, it's kind of difficult. We have a story to tell. We have products that can be unique. And IACME has been a great conduit to bring many SMEs together, talk to people like the Boeings and Lockheeds and many others, all the big automotive folks as well. So we see this Industry 4.0, speed is the big thing always with manufacturing, especially with Industry 4.0, and we think additive manufacturing is a giant tool that will be used for the next coming wave. So my case study here is obviously about additive manufacturing, our experience with it, who we're dealing with, and if you look at the value of ACME to the USA manufacturing, it's the economic growth, it's the speed model that I just described, design flexibility, competitiveness, and the eco or the green aspect of it. We're talking about additively creating parts. Traditionally, you would subtractively make parts. You get a big tool, a big metal tool. The Lockheeds, the Boeings, and the automotive guys, they start with a big hunk of metal, and they need a tool or a mold, if that's a better term that you can relate to, and they're machining it down, throwing lots of metal away, because that's just the way subtractive building is done. And now they're looking at, okay, well, they end up with all these tools, hundreds, thousands of tools massive, expensive tools that can take anywhere from 6 months to a year to create. Now they can do that with additive manufacturing using high-tech plastics, very highly engineered plastics. They can do it in a matter of weeks, 6 days, maybe 2 weeks to build a very sophisticated, complicated tool. Tools that cost traditionally anywhere from a couple $100,000 up to $1 million, depending on the complexity of these tools. And now you can do it for 1/10 the cost. So a tool that maybe cost $500,000 now costs $50,000. Took 6 months to build, now takes maybe 6 days to build. So you can see the scale of what we're talking about here. And if you're these big guys who have all these thousands of tools sitting around, well, you got big warehouses taking lots of room with big tools sitting out there because planes are designed to last, 30, 40 years, a little longer. Yeah, so a long time. So if you need a replacement part, you need that tool to build a replacement part. So you got to put that tool on the shelf and kind of hang on to it. Well, with additive manufacturing of a composite material, say I built my X number of parts for this model, I don't need it anymore, at least for now. You can take that part, you can grind it up, scrap it, recycle it back into a new tool, and 20 years from now, if you say, hey, well, I need a replacement panel for this particular model airplane, you just go to the CAD file, pull it out, print a new tool, and away you go in a matter of a couple of days, right? So you can see where this is headed as far as those kind of applications, but we also have the big parts. Robin mentioned locomotives. We work with locomotives supplying materials to Ollie and the other vehicles out there, not too far from them. We're looking at many, many different aspects. We're not a one-trick pony either. We have many other things we do besides additive. I might point out, through the IACME Institute, we're involved with the carbon fiber technology, and just recently we came up with really the low-cost version of the first textile-based carbon fiber, lower-cost carbon fiber, and through a high-speed injection molding process, did it through the IACME facility up in Detroit, Michigan, the SURF facility, the scale-up research facility, and in conjunction with the Michigan State University, and printed car fenders using a carbon fiber reinforced material. So that's a little distraction from the additive discussion I just had. But if you look at, just to kind of wrap up and pull it all together, you think, well, what else can we do? We can make tools. Okay, yeah, we can make tools. We can make parts. We can make big parts. And as mentioned, there's a printer that would not fit in this room. You have to take the ceiling out and double the height here, push that wall out to fit this additive manufacturing machine. And today it's moving for the first time. It's up at the University of Maine. I can't say too much about it, but they're going to be printing boats and other very large things. So you'll see some stuff coming out of that in the next couple of months. So I don't want to steal their thunder, but to say big things are coming. Some of the other things we did, the Shelby Cobra. I'm sure many of you have seen the Shelby Cobra. That's literally, I think, traveled around the world a couple of times, right, John? That's been going everywhere. But that was a real success story very early on. And we joined IACME back when it was inception 5 years ago. And we're very pleased at our involvement with IACME. And just full disclosure, I'm a past board of directors member of IACME. I turned out on that. And I'm current chairman of the IACME's Financial Sustainability Committee, which I'm working with John Hopkins on. I'm looking at the DOE people in front of me, so we are working on the financials. So some of the other parts of Shelby Cobra, we've worked with the military, the Navy in particular, with the SEAL delivery vehicle, as they call it, so a 6-man or 8-man military type vehicle. And I'm not disclosing anything secret, this has been publicized. I mentioned the aerospace tooling with the big guys who are working closely with Lockheed, the Marietta facility, Boeing, over in the Everett and the other locations, Auburn, with their groups there. The housing I mentioned with Space Factory, the Branch Technology is also doing it. And I've got some videos and stuff and other things I can show you. If you don't, I can send you a link, just let me know. I was also a guest lecturer at the Washington University in St. Louis a little while back, talking to their architectural students. They're very interested in additive manufacturing and what they can do as they're designing architectural type structures. We work with NASA, as I mentioned, on the Mars Habitat process. Construction, precast concrete molds. There's some different things that are coming now with additive manufacturing. Working with Bell Helicopter on helicopter blade tooling applications, windmill blades, utility poles. That's something that's coming out, working with Oak Ridge National Lab. Oak Ridge National Lab is really a great member of this organization, and we work with them quite closely. I've mentioned the boat molds, and something I really can't talk about too much because there's going to be a big splash coming here next year, but look for one of the NFL football teams. Will be in Vegas, the Vegas Raiders, what we call it. They're going to have some really interesting features inside the stadium that are going to be kind of mind-blowing, so stay tuned for that. And we actually had a presidential visit back in 2015. The president and vice president of the United States both came to our facility, in our Tennessee facility, to talk about some of these great advances in additive manufacturing that we're helping do with our involvement with the materials side of it. So to wrap it up and say, we're sitting here in the seat of government where all of our states are represented. And I did a quick study looking at some of the projects that we've been working on. And at least 27 of the states we are doing active projects with or multiple projects with. And if they're not on there today, they'll probably be on there in the short future because of the breadth and how expansive this whole thing has done. So with that, I thank you and appreciate being here.
That was great information. So I think you talked about states. Let's talk a little bit about regional ecosystems and some of the hubs. So you all have been able to connect with a lot of the small and medium-sized enterprises. Can you talk about some of the innovation ecosystems that you've seen the institutes build specifically in your areas?
Sure. So America Makes is headquartered in Youngstown, Ohio. And I tell you, the ecosystem that's been developed around Youngstown, Ohio is phenomenal. We've got Youngstown University, we've got Youngstown Business Institute. There are several organizations now that have co-located around the Youngstown area. And really cool things are happening. We had several of our members talk recently at the NDIA Manufacturing Division meeting about how it has truly changed their future by the ecosystem that's been developed around additive manufacturing in Youngstown, Ohio. We had one gentleman stand up and say, my company was going out of business, but because America Makes being right there in Youngstown, Ohio, and the surrounding ecosystem that came around it, my company today is thriving. So there's lots of success stories like that, but I can't emphasize enough, the ecosystem that forms around these institutes is critical to our success.
Thank you. Jeff, do you have anything to add to that?
I guess just real quickly, one that we've seen that's worked very effectively has been the partnership between it and IACME and sort of this region to the center of the country up from Tennessee up to Detroit. Sharing equipment, sharing technologies has been a very effective way to build, not quite national, but increasingly a national ecosystem. Yeah.
And I would reiterate that point. One of the things we're trying to make sure we're doing is not duplicating efforts. So we want to make sure that all of our equipment and our personnel and our resources are complementary, and we're not recreating the wheel anywhere. We're sharing across Interstate 85 and beyond, or Interstate 75 and beyond. So the facility up in Detroit, we have one of the only presses up there, and we send projects up there all the time. Happy to work together, and the states are working really well together as well. So just want to highlight that. Tom, do you want to say anything ecosystem-wise, or do you think you covered it?
Well, I could say that from my company standpoint, we've invested millions of dollars over the last couple of years into growing our capabilities to support additive manufacturing in a large part, in addition to some other things that IACME is working on. And the tentacles of IACME extend well beyond the 300-some member companies we have now, I forget. But extends well beyond that, working with companies who are not active members of IACME, but again, it's about driving manufacturing in the USA as a whole. And so the reach of IACME is beyond the small ecosystem that really a lot of companies are ancillary.
Absolutely. Thank you all. Just want to highlight, in addition to the technical successes, the technical is driving the workforce. So these two go hand in hand. And the things we're doing on the workforce side are complementary with the technical. So whenever we're working on a technical project, one of the things that IACME, and I know our other institutes are looking at, is all right, what do we need to know in the future? What do we need to think about in terms of training, in terms of including folks in the supply chain, from the technicians to the interns and beyond? So these two things do really go hand in hand. Also want to highlight the impact of our technical societies to our ecosystem. Very thankful for ASME. We couldn't have done this without you guys. You guys were really key in getting so many people here, so thank you so much. We also work with other partners like the American Composites Manufacturers Association, American Chemistry Council, and others that are working directly with the Institute. So just want to give a shout out to the technical institutes and say thank you so much. So, thank you. And I think your time is up, so it's my time to introduce you back. Thank you, Saeed.
Thank you. Well, it's going to be difficult for me to get back there, so let me just make a few remarks. First, I want to thank you, our panel chairs, and I want to thank our panel for an excellent job, and thank you all for all the information you provided. Now, you all have a copy of this, the 2018 annual report, and my offer at the beginning was take 1 or 2 or 3 or 4 or 5 copies with you. Take as many copies as you want. We don't want to take it back to take it. And next, I want to again, well, no, let me mention one thing. We heard about a few projects and a few workforce development activities. In 2018, there were over 500 major R&D projects that Manufacturing USA Institute did. And there were almost 2,000 members collectively in all the institutes. Now, these numbers were for 2018, which ended about a year ago. Now, we're almost finishing 2019. So next year, these numbers are going to be much larger. I mean, in next year's report, in the last 12 months, these numbers have been much larger. I want to thank, well, first in full disclosure, my day job is at NIST, so I know about some of these statistics, and I helped our team to put some of this information together. And my other day job is with ASME, but I get paid by ASME only with love and hard work. Now, I want to thank our team that put together the annual report 2018. Everyone who contributed to this, would you please stand? Is Robert here? Okay, I think, okay, they must have gone and started drinking. So I want to thank all of our ASME staff and all of the NIST staff who work in getting this event and the next event together. Would you please stand and come forward? We really appreciate all your work. You shouldn't be ashamed. You should stand up. You did a lot of work. I know that. Now, our next event is the expo in room 2168, which is 1 floor up. It's called Gold Room. But I don't think it's really Gold Room anymore, because it was called Gold Room because all the drapes were gold. But I think they have all been changed to a different color. We'll find out when we go up there. But before we close and go up there, I want to ask Mike Molnar, Valerie, and Tracy, do you guys have any comments you'd like to share with the group before we all go upstairs?
Yes, I think it's after 5 o'clock, and we have adult beverages to the expo.